Okay, so where are we? Week 8. We're really going to start week 8? Really? This is it? Exponential, 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 exponential. Oh my, exponential. Binomial we talked about. Poisson we talked about. They're both use discrete data, so a 0 or 1 can be on the end if we're using Excel. We talked about uniform distribution. We talked about normal probability distribution. Normal probability always has to have a 1 on the end because it uses continuous data, always a 1 on the end. And now, in the same category with normal distribution is exponential distribution. This does not have a standard deviation. Let me start there. There's only one that has a standard deviation of all of them we've learned so far, and that's normal distribution. You know to use this if there's a standard deviation. That's how fast you should realize it. Oh, standard deviation. Boom. That's it. Here's what is going to make exponential so hard for you. The number one mistake students make is mixing it up with Poisson because they almost read exactly alike. Poisson and exponential almost read exactly alike, so you've got to focus on the difference. Here's the difference right here. When we were working on Poisson, it was all about, hey, what's the probability 5 cars will pull up to this toll booth in the next hour? Hey, what's the probability 3 customers will walk in the door in the next 15 minutes? It was the number of events over an interval. That's Poisson. The number of events over an interval. What's the probability 3 cars will drive by over the next 2 hours? Or 3 cars or more will drive by over the next 3 hours. That's Poisson. Exponential is always about the interval between the events. So when I said Poisson, hey, what's the probability there's 5 cars pulling up to this toll booth in the next half hour? Exponential will say, what's the probability there'll be a half hour between the next 2 cars pulling up to the booth? The question's about the interval between the events. Let me say it again. I want to make sure you see this. When we were learning Poisson, we learned about what's the probability there'll be 5 cars pulling up to the gas pump in the next 30 minutes. 5 cars pulling up, or less, pulling up to the gas pump in the next 30 minutes. That's Poisson. I'm asking you about how many events during an interval. Now I'm going to do the same gas pump, exponential. What's the probability there'll be 30 minutes between the next 2 cars pulling up to this gas pump? The question's about the time between the events. Or let's say a car just left. The question may say, what's the probability it'll be 15 minutes before the next car comes up to the gas pump? The question's about the interval. Because that question's about the interval, that's how you know to use exponential. Okay, now I've got to state this next thing in a way that somehow is going to get you to realize. You're going to read a question. And in the question, there's 2 parts. It describes the mean. It describes the question. What's the probability of something? Do not determine what kind of question you have, whether it's Poisson or exponential, when it describes the mean. The mean can be described several different ways, whether it's exponential or Poisson, and that should never make you determine what kind of question you have. You have to focus on the part of the question that is asking you about to find the probability of something. That is what you determine whether it's exponential or Poisson. Hey, what's the probability of? That's the part you're going to read to determine, is it exponential or is it Poisson? What's the probability of 15 minutes before the next car pulls up to this gas pump? Oh, it's asking about the 15 minutes. It's exponential. Hey, what's the probability that there'll be 3 more cars pulling up to this gas pump in the next 15 minutes? Oh, it's asking about 3 more cars over an interval. That's Poisson. But the mean will be described sometimes the exact same way, whether it's exponential or Poisson. And that's why you cannot use the mean description to determine what kind of question you have. Because they use the same description sometimes. It will fool you. You've got to go forward to the part that's asking you about what's the probability of something. That's how you determine which kind of question you have. All right, now that we talked about that, let's start getting into examples. We're focusing today on just the Excel way to solve these. Just the Excel. And here's if the Excel is about a question of some number or less. Here's if the Excel if it's about a question of some number or more. And just like normal distribution, you don't have to worry about what that first number is. You always use whatever you're being asked about. Whatever the questions ask you is the first number, just like normal. Poisson and binomial, weeks ago, you got to use the opposite. That first number has to be the opposite on a more than question. But with exponential, just like normal, you don't have to worry about the opposite. It's whatever you're being asked about. That's the first number. The hard part is the second number, called lambda. L-A-M-B, like a lamb, D-A, lambda. Lambda is where everybody says, okay, this class is out of control now. I put it in words though. This is lambda in words. You're gonna find the mean number of events, the number of cars pulling up to the gas pump. You're gonna find the mean number of events during, here's the key words, 1 unit of the interval being asked about in the question. Gosh, this is getting hard. This is too much information. Are we on break? Man, this is week 8. You're going to see a bunch of examples. I'm going to keep pointing out these definitions so you can see how these examples make sense compared to what I'm trying to point out here. Blah, 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 blah. Let's get to our first example. Why not? Where am I going here? PowerPoint. Wait, boom. Okay. Here are some examples of the kind of wording you might see in the question part of the problem. Not the description of the mean, the part where they're asking the probability of. So here's 3 of them. What I want you to notice is you're being asked the probability of an interval. You're not being asked the probability of the number of events. You're being asked the probability of an interval, time or distance or something between events. That's the key to recognizing exponential. For example, time between vehicles arriving at a toll booth. You ready? Hey, what's the probability there'll be 15 minutes between the next 2 cars arriving at this toll booth? That's exponential, because I'm asking you about the probability of 15 minutes. That's an interval. The second one says, time required to complete a questionnaire. What's the probability the next student will take a half hour to finish the questionnaire? The question's about that half hour. That's an interval. It's a length of time or distance. And that's how you know it's exponential. The third one, the distance between major defects in a highway. What's the probability there'll be a mile from this pothole to the next pothole? What's the probability there'll be a mile or less between this pothole and the next pothole? That's a distance, that's an interval. I'm asking you about a mile between the events of potholes. That's how you know it's exponential. Now, I just want to give you an example of Poisson using, let's use the last one. Distance between major defects in a highway. Exponential said, hey, what's the probability there's a mile or less between the 2 potholes? Poisson says, hey, what's the probability there's 2 potholes in the next mile of freeway? It's asking you about how many potholes. That's Poisson. Exponential asked you about the distance between the potholes. That's exponential. That's how you recognize it. But both of them will describe the mean amount of potholes in a mile of highway the same. Whether it's exponential or Poisson, it will probably describe it the same. So you can't rely on the mean description to determine what kind of problem's in front of you. You've got to rely on the question itself asking about the probability. So forget the manual formula. We're learning that on Thursday. We're sticking with Excel. I want to take this problem. I want to turn it into an Excel. Don't forget, the first numbers, whatever we're being asked, the interval in which we're being asked the probability of, 15 minutes, 2 seconds, 2 months, whatever the interval is, 2 miles, 8 yards. The interval we're being asked about is the first one. Lambda will be the second one. This is the harder part. Here we go. The time between arrival of cars at Al's, or A1, I don't know what that is, full service gas pump, follows an exponential probability. I will not tell you it follows the exponential probability. You just got to recognize it yourself if it's exponential. With a mean time, so cars arrive at the gas pump at the gas station with a mean time between arrivals of 3 minutes. Where's my pen? 3 minutes. We know that so far. So there's 3 minutes is the mean. That's the mean time, the mean interval between cars. But we got to turn that into lambda. Let's talk about the question now. A1 or Al would like to know the probability that the time between the next two successful arrivals will be 2 minutes or less. Boom. Here we go. 2 minutes or less. Am I using the top one or the bottom one exponential Excel formula? Top. 2. There's the question. You don't switch that. 2 minutes or less. There's the 1 on the end. 2 minutes or less. These questions will always be something or less, or something or more, or at least, or no more than, or whatever those words are. You'll never be asked the exact number because it's exponential using continuous data. So there'll always be a 1 on the end. But now, lambda, I'm putting a 1 here. All we have left is that lambda. Now here's the deal. The mean was described to us as 3 minutes between cars arriving. But the question is about 2 minutes. What's the probability there's 2 minutes between the cars? The question's in minutes. So this sentence right here, 1 unit of the interval being asked about in the question, in this case, is 1 minute. That is 1 unit of the interval being asked in the question, because the question is about 2 minutes or less. So we have to figure out how many, on average, cars pull up to that pump per 1 minute. But here's the deal. A car just left, another one pulls up 3 minutes later. We're not even getting a car every minute. So it's not even 1 per minute. The average amount of cars per 1 minute is less than 1, because it takes 3 minutes just to get 1 car. So we got to figure out what portion of a car is arriving per minute on average, just to get a number for an average. So if it takes 3 minutes for a whole car, 1/3 of a car in the first minute, 1/3 of a car in the second minute, 1/3 of a car in the third minute, lambda is 1/3 of a car arrives per 1 minute, because minutes is what the question was being asked about. How do we feel? We just figured out lambda, but believe me, lambda has to be done. It was given to us as 3 minutes. It could have easily have said, here we go, right here we go. It could have easily said this. The mean is 10 cars per half hour. It's telling you how many this time. Instead of giving you the mean as the time between them, it's telling you how many. This is exactly how means were described in Poisson. But exponential also describes means this way. That's why you go, oh, 10 cars per half hour is the mean? Wait a minute, this is Poisson. No. Exponential could be describing the mean the same way. You've got to get to the question to figure out which one it is. Go ahead, Ali. You got it? You good? You good, Ali?
Yeah.
Okay, let's keep going then. 10 cars per half hour. Let's pretend that's how it's described instead of 3 minutes. Now I got to turn that into how many cars pull up to the pump per 1 unit of the interval being asked in the question. So again, we're back to how many per 1 minute. Well, there's 10 per half hour, which is 10 per 30 minutes is equal to how many per 1 minute? There you go. Now, because the mean was described differently, I just can't figure out how many per 1 minute when that's being told as time. I got to figure out how many per minute based on how many per a different time. So it's 10 per 30 equals how many per 1 minute, and watch this. 1 times 10 is 10, 10 divided by 30, the same lambda. We got the exact same lambda, but our mean was being described a different way.
Can you pick a higher number?
Pick a bigger number?
Yeah, like.
Okay, hang on, I got all kinds of examples coming. And I'm sure one of them is going to be a bigger number.
So, the amount being asked is always the numerator and the time is always the denominator for your lambda?
Yes, kind of. Yes. How many per 1 unit? Well, this will always be a 1, is what you're trying to find for lambda. Well, the 1 will be a denominator. It's just, it could be 1 second, it could be 1 hour, it could be 1 week, it could be 1 minute, whatever the question's asking about. And then, yeah, then your lambda is whatever's above 1.
So when we put lambda in on Excel, is it going to be a fraction or?
Yeah, you can put fraction or decimal, it's up to you. You want to put 0.33333 or 1/3, it's up to you. 1/3 is more exact though, because you'll stop putting 3's when really it goes forever. You're rounding. But either one I accept. As long as you got 4 3's there, 0.3333, I'll take it. All right, let's do another one. Hang on, we're going to the book. We're page 228. Hang on, let me go here, let me go here. We're gonna do number 66. How do I switch? Hang on, I forgot to switch it. I don't hear anybody opening their foot. I don't know if that's a good sign. Oh, thank you for someone for flipping a page. All right. Here, can we see that okay? And zoom in maybe? Okay, 66. We're going to talk about 66B. A toll booth operator has observed that cars arrive randomly at an average rate of 360 cars per hour. Now hang on a minute. 360 cars per hour per 1 hour. The mean is being described to us as the number of events over an interval, instead of being described to us as an interval between the events. Like I said, Exponential has the mean described different ways. So you can't use the mean to determine what kind of problem you have. Because right now you would say, oh, this is Poisson. Because that's exactly how Poisson's mean was described. But then it goes on to say, and I'm going to B now, what's the probability that the next car will arrive within 10 seconds? That's how you recognize this exponential. The question's about that 10 seconds. It's almost as if a car just left and you're waiting for the next car, and the question is that it will take 10 seconds. Within 10 seconds. That means 10 seconds or less, right? Within 10 seconds. So let me go up here. Where'd the eraser go? How could that disappear? Let's go up here. Tell me, am I using, let's see, what is this now? The question's about 10 seconds. Am I using the top one or the bottom one this time? Top one, because it's 10 seconds or less, there's a 10. Lambda. Wait, on the end is a 1. That's easy. Now we have lambda. Here's how the mean is described. The question, by the way, is about 10 seconds. Seconds. Lambda has to be 1 second. How many cars, wait, what is this? Cars arrive to a toll booth? The toll booth operator observed cars arriving. The lambda has to be how many cars per 1 second, because the question's in seconds. And here's all we know. 360 cars per hour. How many minutes are an hour?
60.
360 cars per 60 minutes equals 60. 1, 2, 3, is that right? Is that 3?
That's 180.
8, 6, 6? 6? Come on. Calculators, 360 divided by 6. What is it, 6? 6 equals 6. So that's 6 per minute. But we got to get it to seconds. How many seconds in a minute? 60. 6 divided by 60 is 1/10 per second. 1/10 of a car arrives at the toll booth per second. Do I have that right? Did anybody take 6 divided by 60? Is that 0.1?
Yeah.
0.1. 1/10. Hang on, I'll turn it to 0.1. There you go. 0.1 per second. We converted 360 per hour down to how many per second? 0.1. So here I go. 0.1 is lambda. Lambda is the hardest part of this. Whatever you're being asked about, you're using the number being asked about, you look at what the interval is in the question, and you convert however the mean is being described to how many per 1 unit of the interval in the question. This is the hardest part. It's just starting to get hard now. Ali, did you have another question? I missed it.
Yeah. I know it's not, can you do an example like the homework one?
Yeah. Well, not the exact homework, no.
No, not the exact one, but.
I got plenty of examples. After I do these 2 or 3 more examples, tell me if one was like the homework or not, and then I'll go back.
Okay.
But I can't give you the exact homework. All right, so now we're gonna go to, let's see, that was 67C. Let me move this up. 67 part C. Customers make purchases at a convenience store on average every 6 minutes. Okay, the mean has now been described as an interval this time instead of how many. We went back the other way. And it says 6 minutes is the average amount of time between customers doing what? Making a purchase. Let me read it again. Customers make a purchase at a convenience store on average every 6 minutes. Blah, 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 blah. Here we go. And what I say we're doing, B? 67C. What's the probability that a customer will show up in less than 5 minutes? A customer, I'll say, make a purchase in less than 5 minutes. Am I reading the right question? Less than 5 minutes. Okay, let me get these out of here. Are we using the top formula or the bottom formula? Why top? Because it says less than 5 minutes. C says less than 5 minutes. What's the first number?
6.
No, 5. because it says less than 5 minutes. Less than 5 minutes is the question. Now, because this is in minutes, a lambda has to be how many customers will make a purchase within 1 minute, because that's in minutes. So this, right now, how is it being described? 6 minutes between each one? It's how many per 1 minute. How many per 1 minute's lambda? Why is it 1 minute? Because the question in C said, what's the probability a customer will show up and make a purchase in less than 5 minutes? Less than 5 minutes. 5 is the first number. 1 is the last number. Lambda is the center number, which is how many per 1 minute. There's 6 minutes for a customer to make a purchase. This time is being described as the time. We gotta figure out how many customers would make a purchase, arrive and make a purchase in 1 minute. Well, if it takes 6 minutes for one customer, there's no way we could get a customer every minute. That'd be 6 customers in 6 minutes. So only a partial customer's in 1 minute. And it happens to be, and now what you're about to see, you're gonna go, oh, when it's described as, when the mean is described as an interval, we could just put a 1 over it. And that is the case in a lot of cases. But think it through, because it's not always the case. But a lot of times, when the mean is being described as an interval, just like back here when it was 3 minutes, we used 1/3. Remember, both ways, this came out to be 1/3. Whether it was described as 3 minutes or 10 cars per half hour, the lambda was 1/3. Just like this, 6 minutes between cars, there would be a sixth of a car every minute until you get 6/6, a whole car. So 1/6 would be lambda. 5 comma 1/6 comma 1. Lambda is the tough part of this. Let's do another one before Ali asks a question. Let's do part D, 67D. What's the probability that nobody shows up over a half hour? Half an hour. Wait a minute now. Nobody shows up. What? Let me get rid of these numbers. Nobody shows up. Would that be the top one or the bottom one? Top. What's the first number? I think it's 0, right? Nobody, 0 or less, shows up. A 1 on the end, but lambda now has to be, what is it, per half hour? What was D? Over a half an hour. So this is in 30 minutes. Lambda now has to be per 30 minutes. Oh, I'm sorry. Wait a minute. I gotta make sure I'm saying this right.
1.
What is it? Is it half hour?
By about 1.
Over a half of an hour.
But it's in minutes though, so it'll be 1.
If I did it in 30 minutes, so it'd be per minute. 0 per 30. Why did I put that one up there?
More than 30 minutes.
Man, I can't remember. Half hour? We're gonna have to call it 30 minutes. This is 0 in 30 minutes, so this would be how many in 1 minute?
Yeah, 0.
Which again is 1/6.
What do you mean 1/6?
Because if it's asking for it, ready? What's the probability that nobody shows up over a half hour, over a 30-minute period? Go ahead.
So do you, when it says like half hour, 'cause I'm looking at homework, do you switch that to if the,
You can switch it to minutes or
Yeah.
leave it as a half hour.
Okay.
I accept both answers.
Okay.
That's why there's probably 2 answers to this one
You
too.
get the 6 from the.
Because if it's 0 a half hour, I would have to then how many per hour, wouldn't I? If it's 6 minutes, how many would that be per 1 hour? Here we go. How many would that be per 1 hour? If you get a customer arriving every 6 minutes, another 6 minutes, we're at 2 of them at 12 minutes, another 6, we're at 3 at 18 minutes, how many would that be in 60 minutes? 10. So this now would be in 10. That's a tough question because of the 0 in the front. Let's go, yeah, matter of fact, I put on here, if you use an hour, 60 divided by 6 would be 10 per hour in my notes, so you're right.
Wait, but it's over a half hour. So
Over a
why is
half
it-
hour.
Why isn't it in the 1 minus? Cause isn't that more, like if half hour?
No, that would be if nobody if someone shows up or more. Nobody showing up would be 0 showing up or less, wouldn't it? Isn't it saying nobody shows up?
Yeah.
That'd be not even one person show up. If I put 1 or less showing up, that would be possibility of 1 showing up. But they're saying no one showing up, so I'm just using 0. Go ahead, Randy.
So when you put it in Excel, like 0, 10, comma 1, the probability is 0.
Yeah.
Is that possible though?
That is possible, or so close to zero, they're calling it zero.
Oh,
Try 0.16 1, tell me what you get.
1/6.
Yeah, 1/6, 0, comma, 1/6, comma, 1. You probably should get zero there too also, close to zero.
Yeah.
Yeah. Because nobody's showing up in 30 minutes, when usually you get someone showing up every 6 minutes, it's so close to zero. That'd be no one showing up in the first 6 minutes, no one showing, that'd be 10 people who usually show up not showing up, oh, I'm sorry, 5, because it's a half hour. That'd be 5 people usually showing up in a half hour and not showing up at all. The odds are pretty slim.
Can I give
Rolling
you,
the dice
so-
6 times and not getting the number you want 6 times in a row.
Yeah, it'd be like that. The odds of that are so slim. It was so close to zero. Man, that's even better odds than this happening,
Yeah.
in a way. Go ahead, Ali.
can I give you an example?
Example of question?
Yeah.
Is it from the homework?
No, it's not, no.
Okay, go ahead then.
The whole number.
I'm ready, go ahead.
Okay, let's say the mean is 7. Like the mean.
Yeah,
Seven.
tell me the story.
Okay.
7 per what?
Minutes.
Oh, 7 minutes between what?
Between each year working hours.
No, there's too many smiles on the face, we're going.
No, I swear it's different numbers.
Here we go,
I promise
68,
you.
we're going number 68A. 68A, you ready? I'll read the homework if we got time in a minute. I'll read it and give you some advice. A hospital administrator worries about the possible loss of electric power as a result of a blackout. Now this is tough, because this is 500 hours. The hospital, of course, has a standby generator, and it's subject to failure though, having a mean time between failures of 500 hours. There's the mean, you ready? 500 hours. It's being described as an interval. This is your mean. And now, let's read the question to figure out what we gotta break that mean into. So the question says in A, what's the probability that the standby generator fails during the next 24-hour blackout? So it's gonna fail in 24 hours or less. So, whoops, where's this? Again, this is 24 hours or less. So we're gonna use the top equation, which is the 1 on the end, 24 on the front, 24 hours or less. But lambda has to be how many failures take place per 1 hour. But it takes 500 hours for one failure. So how many failures take place in 1 hour on average when it takes 500 just to get one failure? How many per 1 hour? And this is one of those times where you just throw the 1 over it. There's 1/500th of a failure in the first hour, the second 500th in the second hour, and finally we get to 500 hours, there's the first failure. Only 1/500th of a failure on average takes place each hour, which is next to no failure. And that would give you the probability of it failing in the 24-hour blackout we're about to have. Failing meaning a blackout, or that it turns off and stops working, that it fails. Hang on, I got another one. We're going to 70. On average, the state police catch 8 speeders per hour. Here we go, here's our average. 8 per hour. Here's our average right there. Let me get rid of the rest of these. 8 per hour. Let's see. Per hour. A certain location, Interstate 90. Assume the number is a point. Okay, here we go. And we're doing A. Is it A? Yeah, 70A. What's the probability the state police wait less than 10 minutes for the next speeder? Are we doing the top one or the bottom one here? Top or the bottom one? Let me read the question again. What's the probability the state police will wait less than 10 minutes for the next speeder? Top one or bottom? Top. How many minutes did it say? 10?
25.
10 minutes, comma 1. Let me look again.
25.
What A says, what's the probability of 10 minutes or less? So 10 is the first number. Whatever you're being asked about is the first number. Lambda, which is 8 per hour, because the question's about 10 minutes, right? Is that minutes?
Yeah.
We gotta turn that into how many per 1 minute. How many speeders are caught per 1 minute when usually it's 8 per hour? So here's the different one. We're not just putting 1 over 8 because it's not being described to us as an interval. Instead it's being described, the mean's being described just like Poisson, how many per interval. So we got to change that instead of 8 per hour to how many per 1 minute. This happens to be 60 minutes. So now they're both in minutes, I can cross multiply. 1 times 8 divided by 60. Whatever 8 divided by 60 is, someone do it already? 0.1333333 is your lambda. 0.13333, that's why the line's above it, 333 is your lambda. All we did, we said, because the question's about 10 minutes, we gotta convert our mean to how many per 1 minute, 1 unit of the interval. And since it's how many per 1 minute, 8 per 60 minutes would be blank per 1 minute. 8 divided by 60 tells you how many per 1 minute, which is 0.133333. And that's how you find lambda. Lambda's the hardest part of these questions. Now let's look at the homework for Ali's sake. You ready? Hang on.
Thank you.
Welcome. Here we go. The first one says, a customer service department receives incoming customer calls with a mean of 5 minutes between each call. The mean this time is being described as an interval. This could be one of those situations that are more like 6 minutes, not 8 per hour. It's being described as an interval, a time, and it's 5 minutes. A, what's the probability that customer service department receives an incoming call in 6 minutes or less? The question's about 6 minutes or less, so the mean or lambda has to be how many per 1 minute. How many incoming, is it emails or calls? Customer calls, how many incoming calls per 1 minute, because the question's in minutes. B says, what's the probability customer service department has received an incoming call in 4 minutes or more? Again, the question's in minutes, so the mean would be, or the lambda would be how many per 1 minute. And then C says, what's the probability customer incoming calls for 20 minutes or more? 20 minutes or more. So we're still asking about minutes. So the lambda would still be how many per 1 minute.
The bottom fraction is 1.
I'm sorry, what? I don't know what the answers are. All I'm saying is that it's asking about 20 minutes or more. So lambda has to be how many per 1 minute. Lambda has to be how many per 1 minute. Number 2, real quick. Customers arrive at a local movie theater, have an average of 3 minutes between each on Sunday. 3 minutes is being described as an interval, so it's how many per 1 minute. If the question's in minutes, let's look and see if they are. Question A is about 4 minutes or less, so lambda would be how many in 1 minute. B is about 2 minutes or more, so lambda would be how many per 1 minute. And C says half hour or less. You can switch this to how many per 1 hour then, or you can switch this to how many, you can switch this to 30 minutes or less, keep the same lambda then that you used in A and B, which would be how many per 1 minute. It's up to you. But you gotta switch this half hour to 30 instead of just 0.5, if you're gonna use minutes. All right, there's how you do the homework. Let me see, 2 more things real quick. Fact, F-A-C-T, this is your new way to find the factorial of a number, instead of using the calculator. F-A-C-T of a number, oh wait, hey, why didn't you tell me? You guys gotta get this up on the screen here. There it is, so, F equals F-A-C-T, parentheses, 5 parentheses, 5 factorial, 5 times 4 times 3 times 2 times 1, 120. Give me another factorial. We had 3 factorial was on the quiz. So if I did it this way, equals F-A-C-T, parentheses 3, should be 6. There it is, 6. Real quick, here's one. Equals factorial, F-A-C-T, parentheses 0, 1. I know your instincts will say, oh, the answer's gotta be 0, the result's 0, but it's not, it's 1. The factorial of 0 factorial is 1. Another Excel command we gotta learn is rank. Rank will tell you where a certain number ranks in order, either ascending or descending in a group of data. So as you can see, we got data in column B, 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. It says, if we put equals, R-A-N-K, parentheses, 21, comma, B8 dot dot B15, comma, 0. A 0 on the end says, is it ascending? A let's see, enter a 0 on any at the position for descending. So this means descending order. From largest to smallest, descending. So that means 21 would land in the 6th position. If I said this right, 44 is, let's see, 55 is first, 44 is second, what's the next biggest number? 34 is third, 33 is fourth, there's another 34, so that makes 5, and then 21 is the 6th number in order from largest to smallest. So you gotta remember, you may have 1,000 pieces of data and you need to know where 21 lands in ranking from largest to smallest. You would use rank and put a 0 on the end. Also, right here, you could leave the 0 off on the end. Use rank, and you can say B9, which is the number 21, same thing as putting 21 there, and then comma, B8 through B15, it looks at all the data. There's no 0 on the end, there's no number at all on the end. It's gonna go ascending, meaning from largest to smallest, and it will bring back that 21 is the 6th number again. Now, to go ascending from smallest to largest, you gotta put a 1 on the end. So equals, RANK, parentheses, 21, or you could have put B9, 21, comma, B8 through B15, comma, a 1 on the end. That means now you're going from smallest to largest. You're going ascending order. And in that case, 21 is the 3rd number, not the 6th anymore. The smallest number is 12. The second smallest number is a 20. And 21 is the 3rd smallest number. So that would be ascending order. Over here, all that's changed is we just use the cell B9 instead of putting the number 21. It's still the 3rd number in order. Okay, everybody understand how to use rank? Define, you don't, not how to use it, but could you use it? If I said, what position is 55 in ascending order, how, and you had a ton of data there. Here we go. What position is 55 in? Equals, rank. And I said ascending, rank, parentheses, I'm asking about 55, comma, B8 dot dot B15, comma, and I said ascending, so what do I put on the end? A 1. And now 55 should be, how many numbers are there? 8? And it is the largest number, so it should come up with 8, right? There it is, 8 it is. Now remember, you could have 1,000 pieces of data, and that's why you're trying to use this rank to figure out where a piece of data lands when it comes to, you know, quartiles or something like that. That's it. That's all I got. I will see you guys on Thursday when we'll learn how to do this all manually. Someone left their pen up here. You got here.